Hi, Shantanu. How are you doing?
Hey folks, I'm doing well. Thanks for having me here.
Of course, yes. As you can see, that the audience is definitely our hackers are super excited to learn more about autonomous vehicles and robot taxis from you. So let me bring up your presentation on screen, and then you can lead the way.
Sounds good. Hey folks, glad to be part of this community for today. I'll be giving you a brief overview actually of how autonomous vehicles and robotaxis work. In the next 30 minutes, I'll take you through some of the basic concepts of how exactly autonomous vehicles function and how various companies are trying to scale that technology to a viable business. I'm a product manager at Waymo. This is what I work on and sort of do every day, something I'm very passionate about. And I'm happy to share my experience and a little bit of what I know with all of you. So, start with a basic question. What are autonomous vehicles? Three things. One, vehicles that can navigate their environment without human input. Two, they use software, sensors, and maps to make decisions about where to go and how to move. Three, they can include any types of vehicles. As of today, what we see is cars, trucks, and buses. Some examples of companies that are trying to uh, turn cars into a viable business using robotaxis are Waymo, Cruise, which is a subsidiary of General Motors, Zoox, which is a subsidiary of Amazon, Motional, which is a collaboration between Hyundai and Active, and actively participating with Lyft to do robotaxi rides. A company called Argo, which was a subsidiary of Ford. And then there's a few companies in China. This one out here is a company called Pony.ai. And the last one here is a company called Baidu. Each of these companies in different parts of the United States, China, and the rest of the world, they're trying to commercialize self-driving cars into robotaxi services. There's a couple of other interesting players on the block as well. They're trying to convert trucks into autonomous trucks so that you'd be able to ferry goods from one place to another without necessarily needing drivers. One such example is a company called Too Simple. Another one is a company called Kodiak Robotics. The third one is this really interesting looking truck from a company called Eigendrive. This is based out of Germany. And the last one is actually Waymo. So Waymo had a trucking program. What's interesting is there's one player that's also trying to commercialize autonomous buses to ferry passengers to and from airport terminals. So this is a company in Edinburgh, Scotland. I forget what they're called right now, but it's an interesting use case of using an autonomous vehicle to ferry passengers. So this brings me to a more technical definition of vehicle autonomy. This is how all players in the field calibrate their abilities to drive without human intervention. There's an organization called the SAE. This organization it sets standards for autonomous vehicles. It sets standards for the aerospace industry. It's the Society of Automotive Engineers based in the US. It was founded by Henry Ford himself with a few other people of note. And their biggest contributions to the world include things like setting emissions standards and ensuring that we have a cleaner environment and not all automobiles out there are, chugging out black smoke. So anyway, this organization sets standards, and for vehicle autonomy, they've defined a 5-level standard to define how autonomous is my car, truck, or bus really. So I think most of what we drive today is either a level 0 or a level 1 type of a vehicle. Usually they provide some advanced driver assist features. They provide emergency braking, or they provide blind spot warnings. They're the little indicators that you see on the right side of mirrors of some of the more expensive cars on the road. And they'll tell you when your car is swerving away from a specific lane. On the level 1 side, you've got a car that can keep lane or maintain its position in a lane, so it knows where the lane boundaries are and it tries to center itself in the lane, or it can keep its distance from other cars on the road. So they call that adaptive cruise control. You're able to set how many car lengths you want to have between yourself and the passenger in the front. There's a few companies that are going further than this. So you've got folks like Mercedes-Benz venturing out into level 2 and level 3 autonomy. And that cusp of level 2 and level 3 is when you start giving up more and more control to the machine. So in level 2 autonomy, you've typically got lane centering and adaptive cruise control together so that you can mostly be hands off the wheel. In level 3, you will have the car, level 2 and level 3, you will have the car prod you when you need to take back control. But their level 3 systems are able to, manage navigating low risk scenarios like traffic jams. So when you're stuck in a traffic jam, there's not much movement going on. You're usually at a low speed. At that point, you can hand over control to the machine. And as soon as the vehicle goes beyond, let's say, 20 kilometers an hour, 20 miles an hour, it'll hand back control to you so that you can accelerate and make safe decisions on the road. What you see with these robotaxi services and with the truck services that I brought up on the previous slide is a lot of level 4 autonomy. This gets really interesting because by the time you get to SAE level 4, you are truly not driving. These features, you can have nobody in the driver's seat. And these features allow you to essentially run a robotaxi service. They manage steering, they manage emergency braking, adaptive cruise control, lane keeping, and there's a whole bunch of other features that need to be built so that your car is essentially fully autonomous in limited conditions. So, for example, these cars, they're pretty comfortably able to serve taxi trips in areas like the southern United States where the weather isn't too bad, or where roads are wide and people follow road rules. When we get to the future of autonomous vehicles, everybody's working towards level 5 autonomy. Level 5 autonomy is essentially you can have the car run itself. It is essentially almost like a living, breathing organism. It can navigate every sort of weather in all types of conditions, mountains, deserts, snow, rain, whatever. You probably could put this car in Antarctica and it'll still drive around when it thinks it's reasonable to do so. So this is just a lay of the land of how the industry thinks about levels of autonomy for cars, buses, and trucks. Let's see. The next few slides that I have for you essentially explain how autonomous vehicles work at a fairly high level. So the first thing that an autonomous vehicle needs to do is understand its environment. For this, a vehicle typically has a sensing and perception stack. Think of this as the bundle of all hardware and software that needs to understand where the car is, who's around it, how it should work. That includes things like GPSs, accelerometers, inertial movement units, odometers. So those kinds of systems tell the car how fast it's going, where exactly it is, how many miles it's traveled. Once you've understood where you are on the map, it's still not great because you're able to understand where you are within a few meters. But if you really want to navigate traffic, you really want the car to drive itself, you want to have, accuracy to the level of a few centimeters so that you're able to make the right maneuverable decisions. For this, you typically end up using a much more advanced sensor stack. You end up using cameras, LiDARs, radars, ultrasound, and infrared because they let you know exactly where you are with respect to other people around you. They let you see in the rain. They let you, see at night. They essentially exactly pinpoint the location of the car, its movement, and agents around it within a few centimeters of accuracy. And finally, you've got software that processes the data from these sensors. What does all of that let you do? As I mentioned earlier, it lets you locate the car on the map precisely. Where am I? That's the question the car is asking, and then this allows you to locate that precisely, and it lets you find other agents around the car. There's other vehicles around you. There's more vulnerable people on the road, like cyclists and motorcyclists, who you definitely have to be careful about. There's pedestrians. There's weather objects. So if you've got a massive puddle, may not want to drive the car through that puddle, so that you don't risk sinking your car. If there's hailstorms, you need to worry about those. You kind of also have to worry about obstacles and miscellaneous things. Let's say somebody stopped a car on the road and they're taking out their luggage from the rack on top. You want to be able to avoid that in an autonomous car. You want to be able to make sense of it. A tree branch falls on the road. You want to be able to find that. There is a garbage bag on the road and it's a soft material. Maybe you're okay driving over it. Maybe you're not. And so you need to be able to classify things that are soft debris versus hard debris. And lastly, you're definitely supposed to figure out where sirens are coming from. So in order to follow road rules and be a good citizen on the road, you want to be able to tell when there are cop cars or when there are fire engines trying to get to a destination, and you want to be able to get out the way so that you don't impede their movement. Lastly, and more importantly, you want to be able to identify road signs, things like speed limits, stop signs, zebra crossings. You want to be able to identify where you can and cannot park. You want to be able to identify where you're allowed to honk the horn and where you're not allowed to honk the horn. And so those kinds of things, let the car know exactly where it is, who's around it, how should it behave. Part 2, once you've collected all this data about who's around me, where I am, how I should behave, you essentially end up predicting the behavior of all the agents around you on the road. You've got cars, cyclists, and motorcyclists. As you can see in this image, this is literally the output of a perception stack in a autonomous vehicle. That perception stack outputs what type of objects it sees and what they're expected to do. So you can see in blue, there are a bunch of people that it has predicted are going to cross the zebra crossing. So some of them are looking to cross, some of them not so much. It's identifying that there's a traffic light, it's identifying that there's a wide street, so it needs to wait for people to cross the road. And how is it doing that? It's actually predicting what each of these agents, each of these people, each of these vehicles are going to do. Why is that important? Because if you can visualize this, you can essentially think about vehicles trying to make a decision of where to go. You don't just need to know where the agents are right now. You need to know where they are going to be in the next few seconds. So this helps you build a future state of the world that lets you exactly plan the motion of that autonomous car, what trajectory to use, what speed to use, and how to do all of this legally and safely. The third step in all of this is planning the motion of the car. So you need to decide the trajectory. How should the car move to achieve its objective? How should it decide its speed? How should it decide, steering, what lane it's in, what line it takes to either overtake the cars around it or stay in lane and continue, where it's at. Obviously, the timing of all of these decisions matters a lot. Wrong timing can lead to some pretty serious consequences. And if there's any other maneuvers that the car needs to make, let's say it needs to reverse park into a parking lot, things of that nature, it plans its own motion on board. And then the last step is obviously execution. So all of these motion plans are then converted into signals that can be consumed by the accelerator, the brakes, the steering column, and the mirrors, the horns, the reverse indicators, things of that nature, so that the car is able to execute these actions that is planned. Um, the name of the game in executing all of these actions is essentially to always have zero injuries to customers inside the car as well as other people outside the car, and always follow road rules. So always ensure legal and safety compliance. So that's a really quick overview of how autonomous vehicles work at a very high level. And what I have for you is a little video of how typically folks end up using Waymo. So you'll see what I've explained to you sort of come alive. And what I want you to also take a look at is just the additional magic or the sense of delight that such an experience creates. Before I start this video, I want to clarify that Waymo isn't the only company doing this. I'm sure you'd be able to find other videos of other taxi services that provide similar services and delight to customers. I think the video ends with her saying it was awesome. So it truly is like that. I am privileged to work in an environment where I also get to take some of these taxi rides. And if you all have, at any point of time, access to any of these taxi services, I highly recommend trying it out. It seems a little bit scary at first because you see there's nobody in the driver's seat. But once you get in, it's actually a really magical experience. And in a few moments, most people riding in these cars, they actually forget that there is no driver. In fact, that's exactly the objective of these autonomous cars. You want to be able to feel safe, and you want to be able to want it to be as mundane an experience as possible, so that it becomes a viable transportation technology. Um, there we go. Okay, so sorry. There we go. So this is all cool, but how do you convert this to a real product, a real business? How do you scale this? How do you make it available to everyday people like you and I? As I mentioned earlier, you want to be able to have a service that is safe, safer than any human driver ever. You want it to be delightful. You want it to be more fun. Once you get in this robotaxi, you can play the music of your choice. You can have a confidential business meeting. You can talk to your best friend on a video call, and all of it will be confidential because there is no driver. Um, you want it to be reliable, always available on demand. You want it to be consistent so that, whether it's 3 a.m. and you want to drive to the airport, or it is 2 p.m. and you want to take a quick ride to lunch, you always have it available, kind of like Uber. Um, Part of reliability is also the composed of passenger safety. So there are times when, for instance, less fortunate folks, like folks with disabilities, have a really hard time finding public transportation or finding a taxi that they can easily get into. And so a lot of robotaxi companies are thinking about how can they be um, available to people with these kinds of limitations. Another example of what reliability looks like is, there are parts of the world where having a human driver in an Uber, for instance, is considered unsafe after 3 a.m., especially if you're a woman coming back from a night of partying. I'm sure there is this sense of nervousness about how you're going to feel when you enter a taxi. You don't have to worry about that with a robotaxi because it is truly safe and you're the only person in there. Other than that, you also need to worry about things like how do you make these services more efficient? You want to make them cost as little per trip as possible so that they're a viable alternative to taking things like an Uber ride or a taxi ride. And lastly, if robotaxis are really going to become global and they're going to scale up, you need them to be clean. You want there to be as little pollution as possible. And then you want there to be, you want it to be as great a positive externality as possible. Sorry, I'm seeing a few messages in the chat. Are folks able to see the video?
Uh, so hey, sorry. I think there is, yes, your stream is live. You're able to see
Okay.
it. I think the video that you shared earlier did not. The audio was not there.
Oh, I
Yeah,
see. Okay, gotcha. Thanks.
go
Sorry
for it.
about that. I'll share the YouTube link.
For sure.
Okay. And I think I've articulated how you make it available to everyday people like you and I, but there has to be an incentive for this to become a business, for somebody to start up here. The key question is, how do you monetize it and how do you make it profitable? Without which you won't find investors, you won't find a route to market. It's really interesting and complicated because robotaxis are expensive. Um, so the next thing I want to talk about a little bit are challenges for robotaxi services. The first big challenge is that the technology is still really young. It's really nascent and it requires a ton of testing. Autonomous companies like Waymo, Cruise, Baidu, they're driving millions of miles on the road right now. Uh, Hopefully with clean vehicles and they're not emitting a lot of carbon. Um, so that they're able to understand exactly how humans drive in specific contexts, and then they're trying to replicate that safely with machine learning. So young technology, lots of AI and ML packed in, lots of testing required to do it, and there's many limitations around how many computers you can have on board, or how much energy does that computer consume, and how much is left over for the car. If you want the car to drive around for 8 hours, you want to be able to pack it with enough energy and as little compute as possible so that you're able to serve as many rides as possible with one car in 8 hours. The next big challenge is the safety record. You got these cars, milling about in a city. You're trying to serve tens of thousands of customers, millions of customers every day. Each of those trips, almost each of those trips, has to go perfectly well so that you serve customers, so that you delight your customers and so that you're able to um, get authorization from regulatory bodies to actually drive on those roads. So you need to have a super clean safety record with very little room for error. The good news on this front is that a lot of these companies are already safer than a human driver. If you look at things like collisions benchmarks, so look at the history of human driving in, let's say, the city of Shanghai, and you look at how many crashes happen or how many accidents happen, you will see that autonomous vehicles that are running in Shanghai are probably 100th as dangerous as human-driven vehicles on average. And that's because autonomous vehicles are always present. They're always eyes on the road. They're never inebriated. So you don't have to worry about doing, an alcohol test on an autonomous vehicle. And so that all of those things put together with the tons of sensors that I just spoke about in earlier slides make autonomous vehicles pretty safe. It is still quite challenging to make sure that for each million miles you drive, you have less than one incident that people have a chance to complain about. When you do all of these things, the next big challenge that arises is cost. Robotaxis, with all their sensors, all their compute, all of that motion planning that I described, are super expensive to make. They're difficult to maintain and difficult to repair. For people who are familiar with bicycles and who know how to ride, you know how complex it gets to just fix your bicycle. I had a really hard time doing that when I was a kid, and it took me a while to learn how to fix my bicycle. A robotaxi is a bicycle times 10,000. There's so many moving parts, so many interesting aspects to the robotaxi that need to be perfectly calibrated. They need to be functional. There's, as I said, very little room for error. And so making them and maintaining them is quite expensive right now. We suspect this will get cheaper over time as this technology gets more and more mainstream. Um, another key challenge in all of this is regulations are not standardized. So how the city of San Francisco thinks about robotaxis is different from how the city of Phoenix, Arizona thinks about robotaxis, and that's different from how Shanghai thinks about robotaxis. Some of them are really worried that robotaxis will endanger the public. They will stop police cars from getting where they need to. They'll stop fire engines from getting where they need to. A lot of um, cities, on the other hand, think that it's fine. They've got enough capacity on their roads and they're able to drive those robotaxis around no problem. Um, some of them want to see the data. They really want to see how many incidents happened across robotaxi operators last year to make sure that they are safer than human drivers. Think of this as almost like a clinical trial for pharmaceutical drugs, where you really want to make sure that the robotaxis are indeed safe, they are indeed cleaner than human operators before you allow them to charge for taxi rides in the cities that you intend to launch them in. So yeah, regulations are not standardized. That's a really key issue. Over time, we expect that to even out, as well as countries as a whole, instead of cities, develop opinions and make laws to govern how robotaxis work. And lastly, and probably most importantly, there's public opinion. Some people love these robotaxis, some people just don't. If you are one of those people who, for instance, likes to drive an Uber as a side gig, you may not quite like the idea of robotaxis. Why? Because you might think it's taking up your job. That is truly, a risk to your livelihood, and so you might perceive as if robotaxis are out there to eat your lunch. That said, robotaxis intend to serve a pretty small percentage of customers at the outset. As I mentioned, there's quite a few challenges here before they become mainstream. And so I can assure you, for the next few years, your job as a side gig, if you're trying to drive Uber, is protected. Besides, when you look at large technological advancements, right from the time that humans built fire, call it 100,000 years ago, these large technological advancements have not necessarily taken away jobs. They've just repurposed where humans spend their time. Driving is a repetitive, sometimes dangerous, and a really boring thing to do for most people, unless you're a car aficionado. And even then, you probably don't want to be stuck in traffic in a city 4 hours out of 8 in a day. And so what robotaxis are trying to achieve is they're trying to take the humans out of that equation to simplify those challenges. And so folks that are currently, Ubering as a side gig, eventually they will reskill themselves. Perhaps they will become full-time engineers in autonomous driving companies, and they may, make ML models to make these cars function better. The same thing happened when the tractor was invented. A lot of people that worked in the farms thought, oh, like our jobs are on the line because tractors are more efficient than humans. But we've seen that in general, tractors have brought prosperity to human civilization. Folks that worked in farms obviously developed new skill sets. The same thing happened when, in fact, Uber and Lyft came about. There were, taxi drivers who were up in arms that, oh, we don't want Uber and Lyft in the country, or we don't want them in the city. But overall, it's become a lot easier for folks to use cabs now because Uber and Lyft exist. And taxi drivers have become Uber and Lyft drivers, or they've repurposed, they've learned how to code perhaps, and they're doing something more interesting with their lives. So we see the same sort of arc of technology benefiting human civilization being the big motivation for why autonomous driving should exist and should be able to scale. After that philosophical spiel, I also want to talk about how scaling works for robotaxi services. So, solving for one car might be simple. You might be able to get the car to drive itself. But when you really think about robotaxi services, they're actually quite complicated. They're a lot like the airline industry. They end up serving customer trips. You need to send them back to refuel or recharge. When there's nobody taking rides, you want them to go back to parking lots. When there's something wrong with them, you want them to get repaired and maintained. And lastly, if they really are stuck on the road because some software failed and they've parked away on the side of the road, you want there to be a rescue capability, so that if the car in blue, for instance, goes down, you want there to be somebody who can come and fix it, or somebody who can come extract the customer from the taxi. And so, these are typically the kinds of challenges or things you have to think about when you turn a autonomous vehicle into a robo taxi. So there's a lot of technological development that is happening on these fronts. If you notice, a lot of these actions that I described around charging, parking, maintenance, a lot of them have to also be automated. It's not just the car serving the trip, but you also have to think about what the car does when it is off hail, when it's not serving trips. And so these are some of the challenges that we're working on right now. There's very interesting technology that's used to solve these challenges as well. And I spend a whole bunch of my time thinking about these challenges on a day-to-day basis. Um, and I think that's the end of my presentation. Happy to get questions from you. Happy to have your feedback on the chat and otherwise.
Awesome, great. That was an amazing presentation. Thank you so much for sharing your thoughts with us, Shantanu. I guess we have a few questions that the comment section has.
Sure,
And while they are typing all of those out and then getting their thoughts together, I do have a few questions myself. I was wondering
go
if I
for
could
it.
use them. So it's great to actually, I didn't know so much about robo taxis and that there's so much thought that goes behind a robo taxis and autonomous vehicles because, of course, I get like, of course, there is a notion behind a new mode of transportation now, and so there is a public perception and acceptance towards it, and it is being evolved over the years. Now, what do you think that, like, what are some steps that you think are being taken to ensure that there is trust that is built into these new modes of transportation? And then, of course, this is a rapidly advancing technology, so I was wondering if you had some thoughts on that.
That's a great question. So, if I understand correctly, you're asking, this is a quickly advancing technology. How are different robotaxi operators building trust
Yeah,
in their system so that folks are okay to take the rides? Correct?
of course. Yes, because
Okay,
as you said, there is no one driving the car, right? So it's just you trusting a machine.
makes sense. I think there are maybe three or four things that, at a very large scale or very high level, that a lot of these robotaxi operators do to make sure there is trust in the system. The first thing, as I talked about, is tons and tons of testing. They're able to test these cars day in, day out, in at different times of the year, in different forms of weather, things like that. They're able to essentially build in disengage mechanisms in these cars, so that if the robotaxi does something unexpected, you disengage it and turn it into a manual car again. So you have a safety driver behind the wheel.
Oh.
So this testing really establishes a data-oriented safety profile or performance profile for these cars. The second thing that you do is you take that data and you take it to a regulator. So in the US, there's this regulator called the NHTSA.
Mm-hmm.
Um, it's a regulator that defines safety standards on freeways and safety standards on the road. So you get that regulator to inspect all of your data, and all of the weird incidents that happen to your car, you try to be as transparent about them as possible, so that they're able to inspect them and make sure that those incidents are either not repeated again
Mm-hmm.
or that they are not safety critical, one of those two. I think the third key thing is actually getting customers into cars. So, as with any technology, there is a population of influencers and early adopters that don't mind exposing themselves to a little bit of risk. They go get inside a car, shoot a video. That the video that I showed you was an example of that. Like, they were early riders with Waymo that trusted the technology for what it was worth then. Once you take that ride, it really allows you to lower your guard and allows you to talk about it in public, and then more people will come and sit in your car, ride it around.
Mm-hmm.
So it follows a similar adoption curve to other technologies, quite like the airlines.
Mm-hmm.
If you look at how the airline industry built trust, I think it was by making sure they had a clean safety record in the early years, and making sure that enough passengers got on board, took their flights, and there's a mix of influencer outcomes, word of mouth, advertising, things of that nature that make it sort of normalized for
Mm-hmm.
other people to to take these rides. So I'd imagine these are like the 3 or 4 key mechanisms that folks use to earn trust with
Yeah.
customers.
That makes sense. And I could also see, like, for example, I visited Europe once, and then there was these trams that I could see which were active on road, and most of these trams were operated like there was no manual operator on those trams. It was being operated by a mechanism, and they also took care of the fact that there were like people who would be pedestrians crossing the road at the same time. There would be other ways of like other vehicles who would be crossing at the same time, let's say a crossing. So basically, there were I think there are already mechanisms in place, but I understand that there would still be, in terms of like taxis, there would still be some a hitch that people need to come over. And as you rightly said, it is there with every mode of transportation. It was there with airlines, so it definitely needs some just people getting comfortable with it through different means. But yes, thank you
Yeah,
so much for answering that question. Uh,
certainly. I see
awesome.
one other question from Tintin.
Yes, let me share that up here. I know it's a huge one. Oops.
Can the autonomous vehicles and robotaxis able to perform a self-analysis to diagnose technical constraints, detect those malfunctions, and generate audio-visual digital awareness alarms to the dashboard to see if there's to send to the driver? Great question, Tintin 1992. It doesn't exactly work like that. So what you are describing is already a functionality that many of these cars have, but only when you're testing. When you're testing, there is a driver in the front, and that
Mm-hmm,
driver knows what to do with the car if something goes wrong. So
mm-hmm,
you've got these audio visual cues for drivers when, let's say, some computation doesn't go as expected. Let's say when there is dirt on the camera. That's a very frequent thing when there's rain, like there's water and dirt on the camera. Then there will be an audio visual alert to the driver saying, hey, you might want to stop and clean the camera before you can go on.
mm-hmm,
And all the same, if you and I are sitting in that car, there's no point putting in any alerts there because you and I can't do anything about it. And so you really have to think about who's in the car. If it's a safety driver or a test driver, yes, this makes a lot of sense. If it is an ordinary taxi customer, sending them that alert's just going to make them more nervous, and so you don't send them those alerts. I
mm-hmm.
hope that I hope that helps.
That's definitely yeah, interesting way to look on things. But yes, definitely. I think I have another question about a check-in link. I'll be sharing that shortly, Tintin. But yeah, if folks you have any questions about the topic at hand, about robo taxis or autonomous vehicles, just please make sure you put them in. And yes, we can take them now. We still have a few minutes left in the presentation, so we can just talk more on those lines. Great. So yeah, while folks are typing in their question, I do have another thing that I wanted to ask
Sure.
you. Because of course this is a really interesting topic. So I understand that there is a lot of real-time processing happening when you're talking about robo taxis. They're on road. You have to be fast at this. The speed needs to be needs to be faster than in terms of reaction response times and etc. So
Mhm.
how do you go about planning that as a product lead for set systems?
How do I go about planning
Yes.
exactly how the system evolves?
Yeah. So basically, how do you consider all of these? Like, what's the system behind it? How do you do it? And then how do you plan those things? So, like, there are two
Oh,
questions,
yeah,
but I will.
sure. So, as I mentioned earlier, step one is essentially figuring out where everybody is and where the car is.
Mm-hmm,
You do that with sensors.
mm-hmm,
You identify who's around you. So, as you can see in the image on the left bottom,
mm-hmm,
what they're, who's around you, how you expect them to behave. And so you build a prediction model.
mm-hmm.
Um,
And
that
then,
prediction model will, predict motion profiles of all the agents on the road.
mm-hmm,
So you've got, some kind of hardware, software doing this. Typically, there are pretty powerful computers on board these cars. One example is they've got NVIDIA um, uh, graphics processing units. There's a company called Mobileye which makes these. So these compute units, they essentially analyze the sensor data in real time, and then they use software to predict exactly where other agents will be. So you build trajectories in
mm-hmm,
space and time for each of
mm-hmm,
these agents,
mm-hmm,
and then you run um, So you create candidate trajectories. As you see in this image, this car is essentially creating multiple trajectories
Mm-hmm.
to see how it can best land in this orange oval area out here,
Mm-hmm.
by accelerating, braking, changing lanes, steering, things of that nature. So before it makes these trajectories, it has to know where these two green cars are going to be
Mm-hmm.
a few seconds or a minute from now.
Mm-hmm.
And then it can formulate these trajectories and pick a trajectory. So the formulation of the trajectory and the picking of the trajectory also happens on board on the computer in the car.
Mm-hmm.
Typically, you use machine learning models to do this, to synthesize trajectories that essentially are legal. None of these trajectories will go through one of the cars, for instance. They have to be safe. They have to be legal.
Mm-hmm.
So you generate those trajectories based on a certain set of constraints, and then you use a machine learning model to cost out the safety cost and the energy cost and the comfort cost of each of these trajectories. So if you were to take the trajectory that goes, to the far left of the road, that's
Right.
bad because it sets you right off the road. So there's a
Right.
very high cost to taking that trajectory. If you
Mm-hmm.
take one that is too close to this green car, there's
Mm-hmm.
a very high cost of it being uncomfortable to the person in the car. So you end up taking a trajectory that looks something like this, which
Mm-hmm.
lands you right in the middle of this orange spot. To do all of this, the car also needs to know what the map looks like so that it can formulate where this orange oval spot must lie and then pick which trajectory is best serving the car's purpose. All of this uses a whole bunch of AI and ML, sort of to decide exactly how the car should move. Did that answer your question?
Definitely. And so, if, like, for example, I also come from a country, India, and there is a lot of no perceptions in terms of traffic rules and other things in which there is a lot of rash driving, let's say, in some
Mm-hmm.
roads. And so, in that situation, it would be difficult for these like basically robo taxis and autonomous vehicles to figure that out quickly. Is that something
Yeah.
which is being accounted for as well as one of the parameters?
Yes. So, yes to both of those things. It is extremely difficult to drive in, especially in certain parts of Asia where drivers often, they take road rules as suggestions rather than rules. Uh, and so, yes, it becomes extremely challenging to drive there. But we have evidence of companies like Baidu or Pony driving in Shanghai, and Shanghai is actually a really busy city. It's got a massive population. It's extremely dense.
Mhm.
People tend to follow rules there a little bit more often than they do in India. So India is definitely it's the pinnacle of all challenging driving scenarios.
Yeah.
It'll be a while before you're generally able to find a taxi in India that is self-driving.
Mhm.
um, but the way that we tackle those, so there's two ways to tackle this. First is just generate more data. The better you get with predicting how people around you are going to behave, the
Mhm.
better your driver becomes. And this is very similar to humans, right? Like for folks who have experience driving in India, the more you drive, the more you realize where you need to slow down, where you need to speed up, uh, which agents on the road around you are credible threats, and which ones you can sort of muscle out of the way. So all of these behavioral characteristics of drivers can also be learned by this machine learning model, the
Mhm.
set of machine learning models. And so the one way to do this is to generate a ton of data and train these machine learning models to behave as a normal driver in that city or in that country would.
Mhm.
The second way, and let's say the faster way to market, is to restrict the areas in which you drive these cars. So, for example, in India, on the roads, people may not follow the rules very well, but they
Mhm.
might follow the rules really well inside an airport.
Mhm.
Where you have to take a flight and you exit the gate,
Yeah.
get into a bus, go to the aircraft?
Yeah.
That's, for instance, a really controlled environment. And
Right.
so a lot of companies will try and commercialize tech so
Totally.
that they're able to drive in limited scenarios.
For sure.
Yeah.
Wow, that's so interesting. Okay, so I saw that we have another question about the research study that you suggested.
Yeah.
Uh, our audience was wondering if you can share some links with us about
Oh,
that.
sure. Certainly. Let me
You
see.
can put those in the private chat, and I can share it with the audience.
Sure.
Great, awesome. Yes. So yeah, well, like, there might be some more questions coming up. Another thing that I was wondering if we can talk about is like something about your life. So your day to day as a product lead for Memo, can you tell us a little more on that?
It's interesting. So it is. It's it's an amazing company to work for. I have incredible colleagues. They all work towards the same mission of safety and reliability. To be honest, um, it's some of the most brilliant sets of engineers, data scientists, product managers, and operations teams that I've ever worked with. They really know what they're doing. They obsess day in and day out over exactly how customers can have a safe, legally acceptable, and a delightful experience in these robo taxis.
Hmm.
My day usually is, if I were to think about how it's split up. About 30% of it goes into understanding exactly how customers experience our robo taxis, what they like, what they don't like, just reading up feedback from what customers are talking about. Uh, Another 30% of it goes into working with engineering, figuring out how we improve, you know, um, off-hail behavior for cars, for instance. Like, where do I send a car when it's done serving rides? Like, where do I send it to refuel? Where do I send it to get cleaned or get maintained?
Hmm.
So these are the kinds of things that I'm working on. So I spend about 30% of my time working with engineering to figure that part out. Um, Another 30% of time I end up spending on the operational part of this. So um, if there are any issues with specific cars, or if there's new kinds of data we need to collect, I need to work with operations teams to send a car out in the field, collect data, um, to be able to go through specific logs that are generated by onboard systems and figure out what exactly is going wrong,
Hmm.
tinker with configurations a little bit so that we make that experience a little bit better. That's 30% of my time, and then 10% of my time, I try to focus on learning, because as I mentioned, this is a nascent technology, and I need to sort of
Yeah.
keep up with the game to be in the game.
Hmm.
So there's a lot of new stuff that I need to sort of really dive deep into and learn really well before I can turn that into practice and sort of professional outcomes.
Makes sense. And Shantanu, in your day to day, I know you discussed like you're doing a lot of things. What's your most favorite part? What's your favorite part of the job?
Well, I think it's actually looking at customer feedback. Um, I mean, that's uh, I know it's a pretty stereotypical product management line, but that's essentially what takes up a bunch of my time, and it's what I love to do.
Hmm.
Um, when I want to have, when I want to have a happy high, I literally go and look at customers' feedback. Folks that have enjoyed riding the service, because every time you step into the car, and even now, I've taken hundreds of rides so far. Even now, when I step into the car and it starts its journey, it is so exciting and so delightful. And I've noticed myself sort of zoning out after 5 or 10 minutes, realizing that this is just as good as a human-driven car, and I really love that experience. And I love it when other folks have, they're talking about shared experiences that look like that. And then when I'm trying to motivate myself to do better, I look at the negative feedback. What went wrong? Why did a car stop in the middle of the street? Why did a customer not get the drop off they're looking for? Why were they dropped 5 buildings away instead of where they wanted to go? Um, and so diving into that and understanding exactly how all of that works, um, that motivates me to just make the product a lot better, make it safer, make it more delightful.
That's amazing. I never have driven like sat in a Waymo car before, but this definitely makes me want to ride in one, and it's a
I
great
would highly
experience.
recommend it.
Of course, yes, it's lovely to hear about your experiences.
Yeah,
Okay, I think there these were the questions that we had. I will share the check-in link with you folks. I think somebody already shared it, but I can share that again. This is a registration link that we have for the session. If you attended, please consider registering. And yes, that was great to hear from your experiences. I know that there is so much more to robotaxis and autonomous vehicles than this it was discussed here. And as you said, it's a nascent technology, new technology. We're learning so much day to day. that it keeps on changing. But I am glad to hear that, like, I'm glad to hear that it's going in a direction where people are getting more comfortable with it and people are super excited about this new technology. I think we have one more question that we can take, which is autonomous vehicles and robo taxis connected at a highway network as an Internet of Things mobile object? What are your thoughts?
Um, yes. So a lot of principles that apply to IoT also apply to robotaxis. They are connected 24/7. There are huge cloud servers that monitor what these robotaxis are doing at every instant. It's like, you know how there's an ATC for airlines? Just the same way there is a control system for robotaxis. They exchange data over known protocols, just like IoT devices. They have to worry about how much data they're sending and how compressed it is, just like IoT devices. They need software updates, they need device management, they need device security. They are vulnerable to malicious intent,
Hmm.
so they need to be very cyber secure. All of those things are they directly translate from the IoT world into robotaxis.
Wow, that's so interesting. Uh, cool. I think that answers your question. Let me know if you have any other thoughts, Tintin, and we can take those up as well. But yeah, I think that's about it. Thank you so much,
Great,
Shantanu, for taking time and talking to us about your journey and about your experiences with autonomous vehicles and robotaxis. It was great to hear from you. And
thank
yes,
you.
thank you so much. Happy
Yeah,
hack.
thanks for the opportunity.
Of course, yes, it's great to have you join the community. We've a
Yes,
bunch of great hackers here, and they love to learn, they love to learn more about new experiences, and it's been great for them.
certainly.
All right. Thank you so much, everyone. Have a great day. Happy hacking. We still have a month-long hackathon running as along with our Global Hack Week celebration. So please do consider participating in them. It's an awesome way to build new things and learn something new, just like this session. Great. Thank you so much, everyone. Have a great day. See ya.